Good afternoon, everyone. My name is Abhishek, and I'm a consultant with Pantasign CA. So, uh, so my topic for the day is building a secure foundation using the hardware root, attestation of trust, and PKI combined together. So this is something which is not new. However, we see and use it on a day-to-day basis and experience in our lives. But we are trying to come up with a solution which we are trying to move to implement at a central level to safeguard the do something at the country initiative. So why do we want to build a security foundation and why it is important? So the most important factor is that it helps us and gives us security and protection for the data and information that we have. So with the large advent of digitalization in the last decade, what we see is that we have been using digital on every aspect of our lives. It's like we say that digital is a part of life, but I would like to say that it's more of a way of life now, and we're thoroughly dependent on digital devices. So it is important that we safeguard those information and data like our personal information, our financial information, a lot of other things are there. So a security foundation helps us alleviate those risks and gives us a better security posture and gives us a long-term resilient to stay aloof from such threats. So the components that we are talking about is building a centralized attestation system, and the core components of a centralized attestation system is a hardware root of trust, which is the security foundation of any device. It is the secure foundation of any device, and the key function of a hardware root is that it establishes trust between the different components of a computing system. That is, we can say it's primarily because of its key features like it is immutable, it does not allow any malicious code or alterations in the boot, and allows for a secure boot of any device. Secondly, typically all the hardware roots are capable of performing cryptographic operations like key generation, storage, and other functions like signing and all. And then again, it acts as the trust anchor. That means that any security protocol that is happening on the device is actually enabled through the hardware roots. So typically the trends or scenarios where we see the hardware roots in actions is, which is coming up is the IoT devices, which is like major changes in our ecosystem. We see a lot of IoT devices around which are have chip-based controllers and all. What we want to say is that we should have a secure communication channel for all these IoT devices to connect and communicate with the central systems in a secure manner. Similarly, we have critical infrastructures, that is like healthcare, energy, telecom, finance. They're all adopting hardware roots to have a secure environment to ensure that the applications that are running and operating on such network or systems are secure enough that it does not allow for any tampering, because we are largely dependent on it. Secondly, thirdly, we see that cloud and edge. So we have been used to these OTT channels and all, and a lot of other things are coming up. And most of them are using edge computing now to give you the data at the nearest pop, so that you get access to them, the data or information that you're trying to access on a very faster manner. So the process of data share between all these components together, the hardware roots again are playing an important role there. Like Amazon is a large use case, Azure is a large use case which are using this. Similarly, with the advent of AI, we see a lot of AI coming in with Gen AI and all, and largely many of applications are also evolving which are depending on these AI outcomes. So the outcomes should not be untrustworthy or where we can rely on without any assurance. So the hardware roots will actually add up an assurance level that the information or the outcome that is coming off such AI systems are something which is trustworthy enough that we can rely on to make decisions. So attestation of trust is another component of what we're talking as the central attestation service. So attestation of trust is a secure process for any devices that we're talking about today, so that when they connect or when we are using, so attestation of trust is a mechanism, it's a secure mechanism which allows to validate the integrity of the device cryptographically. So what we intend to say is that there are typically three on a very simple manner that I've tried to explain here, that we see there's an attester, the person who's actually the originator of the data or the information. Then we have a verifier system, and then we have a relying party who's going to consume the information that we are passing on. So now what happens is the attester would push a request to the verifier, which is a attestation evidence, and the verifier would sign up and give the verification result back to the attester, and then again that is relayed back to the relying party, which is the attestation result, so that they have an assurance or the information or data that they're using is actually thoroughly secure. So the prime functions or key features, you can say, they give you a security assurance, they establish trust, and they also help you to be compliant and be integral. So the large use cases, what we talk about attestation of trust is some of the most popular ones, because all of us here would definitely be using a mobile phone, and in some or the other manner we are every day using this attestation of trust service. Largely two of the most prominent ones, Apple and Google, because most of the phones are today either Android or they are iOS. However, there are other examples as well, like Apple, Microsoft, Amazon and all. So there are two features which we can say about the Apple and Google implementation. So all the Google phones today, they have a attestation or a hardware trust, which is actually a TE based, which is a trusted execution environment. It's again a FIPS certified, and they ensure or assure that any application that we are installing or devices that are connecting are thoroughly secure, and they connect to a centralized Google Play Secure services, and they come back. However, Apple has got just the same implementation, but on a different style, that they are more on the platform, or you can say it's a TPM based, it's more hardware-like, and it is also a FIPS certified, and they also do the same thing. So any application or any information that you're storing on your Apple devices, they are thoroughly secure above some of the certain ranges, like say they say that above iPhone 11, they got a dedicated security controller within the device itself. And on the Android side, we see the larger or the higher end models, they have such implementations. So what we're saying is that the three concepts, the hardware root, the attestation and PKI, they can combine together to build a combination framework which can particularly help us challenge or particularly context the evolving threats like quantum computing. Like they give us an enhanced security with the multi-layered defense. They help us build all the trust and compliance requirements that we have, and also future-proof ourselves from the next generation of cyber security threats or challenges that we may face. So this is the main one that I was talking about, that we propose or move to build a central attestation service, which is to maintain a centralized record of controllers that manages the trust request from trusted devices within the country. So why? Because we talked about the threats and all, and similarly, number one, we said that most of the devices that we use are not in our control. So there may be a chance that we may lose to impersonation or lose our device hijacks and all. So building a central registry would actually help us alleviate us from such unknown threats or thorough dependency on external agencies and all. So the central registry is one which stores all the hardware roots within the country. It gives us an enhanced security, threat protection, and then again what we say is that we should embed the PKI within it, that the CCA root, so that it becomes a non-repudiable trust instance. So I have done a basic concept architecture of the CAS system, which says that there's a there's a device which is originating the request, or they're coming into the network. So they pass on the registry information or the image of the device for a registration of their devices. So these are basically a layer of, set of REST-based APIs, which can be thoroughly authenticatable, that any device or application that they're talking to secure APIs. And then they first, whenever they send a request, they would actually get into the registry, which is maintained at the centralized layer. And then again, whenever an attestation request is sent, that again is forwarded to the trust gateway, and from the trust gateway, it goes to the device check, whether the device is available, the information keys are there or not, and then it gets signed up, and then it is returned back on the same channel to the requester, and from the requester, it is on a different channel sent to the relying party, and the relying party on a different part sends the request back to the trust gateway for a verification of the attestation, that the attestation response that was given by the CAS is again verified on a different path. That makes it a thoroughly secure fundamental framework, that the verification request, the signing request and the verification request, both of them travel in a different path and make them highly secure. So that was the flow. Some of the challenges that we see to build up such a network or a framework in the country, that the policy has to mature with the government policy and support has to come into the picture. There has to be a lot of OEM cooperation or the chip manufacturers cooperation for getting those trust routes to be built inside the registry. And then we have to have a timely development to get this framework in place, because of the advent of the quantum threats coming in like another 2 years, what we say. And these are some of the advantages of the CAS, that it will ensure and enhance the national security and ensure that only trusted devices and applications operate within the country. So some of the features like application, key advantages like application security, quantum, it becomes a quantum ready system. And then it also allows us for a seamless migration from the present system to the quantum ready system, that it gives us time and a lot of advantage in terms of the migration cost. It helps us reduce the cost of migration to the quantum era and also saves our time. So, and all these through a robust communication platform or an instance within the country. So with this, I will end my talk. I thank you so much for the time, and thank you for having me here, and thank you CCA sir and Deputy CCA sir for the opportunity to speak here. Thank you so much. I'll take my, thank you.